conversion of base 10 numbers. So you know that when you are doing conversion of numbers, conversion of base numbers, okay? So we can convert from decimal numbers to any base number, okay? We can convert from decimal numbers to any base number, okay? So what is the process of converting from decimal to any base number? Say 7. 7 is a decimal number. I don't have to write 10 as a subscript here because anything that has no subscript is a decimal number, okay? I want to change this to base 2. How do I do this? What is the process?
Divide by 2.
Yes, long division, okay? So any decimal number that you want to change to any base, you do long division. The number that you divide with depends on the base. So in this case, you're going to divide 7 divided by 2 until you get no more remainder, okay? So this is 2 times 3 is 6. We have remainder 1 divided by 2 is 1. Remainder 1 here and divide by 2, 0 until you reach 0 here, okay? Remainder 1. And when we read from the bottom to the top. So this is equals to 111 base 2, okay? This is the same process that we use for any base, okay? If you want to divide 7 to base 6 number, then we divide by 6. If you want to change it to base 5, we divide by 5, okay? So this is the first conversion, okay? Second conversion is any base number, okay? Any base number, you want to change it to a decimal number. So what is this process called? Okay, let's do the same thing, okay? 111 base 2. We want to change this to decimal. So we write it in the form of expanded notation and then we total it up, okay? So how do we write this in the form of expanded notation? Write it to, we use the base. So this is base 2 numbers. So the first digit is 2 to the power of 0, 2 to the power of 1, 2 to the power of 2. This will be 1 times 2 to the power of 2 plus 1 times 2 to the power of 1 plus 1 times 2 to the power of 0. Okay, so this is 4 plus 2 plus 1, which is 7. Okay, 4 plus 2 plus 1 is 7. Okay, so when you want to change any base number to decimal, you just write it in expanded notation. So if you had another example, say you had this number 25 base 7 and you want to change it into decimal, so this will be 7 to the power of 0, 7 to the power of 1. So write it in expanded notation, 2 times 7 to the power of 1 plus 5 times 7 to the power of 0. So this is 14 plus 5. So you have 19. Okay. Okay. So this is the process of conversion. Base number to decimal, use expanded notation. Decimal to base number, use long division. So are we clear with this? Any problems here?
No,
No?
madam.
No.
Okay. So now, but sometimes, uh, okay, but sometimes when you want, sometimes you have a very long number like this, okay? You have a very long base 2 number and you want to change it to another base so it becomes very long. It's a very long, tedious process, okay? Okay, before I go on to that, I have to tell you this, okay? We did earlier, we did from decimal to any base and any base to decimal. What if you want to convert from one base, any base to any base? Okay, how would you convert, say, to say 25, 25 to the power of 8? How would you convert this to base 2?
First, we have to change to decimal number
Okay, and
then convert to binary.
yes, so we have to go through two steps. 25, 8 change to decimal number, okay? And then decimal number change to binary number. So you have to go through these two steps, okay? Everything else is one step, but any base to any base is two steps, okay? Okay, is there any shortcuts or easier way of doing this that you know of?
No,
Okay.
madam.
Okay, so let's look at some shorthand conversions. Okay, shorthand conversions can be used for base 2, base 8, base 16. Okay, why base 2, base 8, base 16? Because base 2 we know are binary numbers already. Okay, base 8 numbers. Okay, 8 can also be written as 2 to the power of 3. Okay, 16 can also be written as 2 to the power of 4. That means these two numbers can easily be converted into binary numbers. Okay, because they're actually the same base if you rewrite it. Okay, so if you look at this table here, base 8 base 8. Let's look at base 8 numbers. Okay, so base 8, the digits are 0 until 7, correct? We have 8 digits here, 0 until 7. The largest digit here is 7. Okay, the largest digit is 7. And 7 in base 2 is 111. 6 in base 2 is 110. 0 in base 2 is 0. Okay, but 7 is 111 is 3 digits. I can also write 0 as 3 digits, right? I can write this as 000. 1, I also can write it as 0 can be written as 000. If I want to write in 3 digits, 1, I can write it as 001. 10 is also same as 010. 11 is 011, and then the rest are all 3 digits already. Okay, so this is, so can you see that? So you see base numbers, the digits for base 8 can be written as any 3-digit base 2 number. Can you understand that? That means you can replace any digit in base 8 with a 3-digit binary number. Correct? Correct or not, according to this table? So 5, you can replace it with 101. 6 is also equivalent to 110 in binary. 1 is also equivalent to 001 in binary. So we need to just understand this so that we can do the shorthand, okay? For base 16, we have 16 digits, okay? We have 16 different digits here. And you can see that F, the last digit here, is 111. There are 4 digits in this base of 2 number. E is 1110, also 4 digits. So we can also write all these numbers in 4 digits, right? For 16, okay? So 0 is also equal to 0000 in base 2. 1 base 16 is also equals to 0001. It's the same, okay? 2 in base 16 is also equals to 0010. 3 is 0011, and so on until we get here. So you see the last digit in base 16 has 4 digits. All the digits we can replace by 4-digit binary numbers. Okay, so that's the first thing that you need to understand for shorthand. Okay, first thing is each base 8 digit can be replaced or is equivalent to a 3-digit base 2 number, and each digit in base 16 is equivalent to a 4-digit base 2 number. Okay, why they can be written as base 2? Because you can write them as to the power of 2. Okay, okay, now let's look at the shorthand. Shorthand itself. Okay, let's see how we can change from octal to binary. Yeah. Okay, before that, I'd like to show you this calculator. Okay, it's an online calculator which you can use to change any number. Okay, so here we have some numbers here, 4, 7, and 5. Okay, we want to see how we can use the calculator to change these numbers from octal to binary. Okay, so the first number that I want to change is 4. Okay, so what is 4 in binary? So we know from here, we know that 4 from binary is 100, correct?
Yes. Yes.
Okay, so I'm just using a calculator here, okay? Of course, you can refer to your table also, okay? So 5 will be 101, okay, from octal to binary. And 7 is 111, okay? So let's remember this, okay? And we go back to our board here. So we know that 4 is 101, okay? 101. 5 was 1, sorry, 4 is 100, 5 is 101, 7 is 111, okay? This is what we got from the calculator just now, okay? So octal 475, okay? Let's look at what is 475 first, okay? 475, okay, what is 475? It is 100111101. Okay, this is what the calculator gives us, the 475. Okay, so when we go back here, we got 475 is 100111101. Okay, so from here, okay, from these 4 steps here, what do you think is 547?
101100111.
Yes. So what can you deduce from here? That means any octal number we can change to binary by replacing or changing each digit into a 3-digit binary number. We know here 4 is 100, 7 is 111, 5 is 101. Okay, so 475 will be digit 4 is 100. This is digit 4, this is digit 7, this is digit 5. This is digit 5, digit 4, digit 7. So if I gave you, how do you change this to binary? One,
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 101,
101,
100.
100. Of course, we write it. Finally, we will write it as this, okay? 1002, okay? That means each digit here, we change it into a 3-digit binary number, okay? So, supposing you had a number like this, okay? 10110 1010. To change this binary number to octal, we are going to divide this into threes, okay? Starting from the least significant digit. So your least significant digit, is it on your right or is it on the left? I did this in the last lecture. I told you which is the least and which is the most significant digit. Least significant digit is on the right or left? Take a guess lah.
Right.
Yes, it's on the right. Okay, so starting from the right, we are going to divide into threes. Okay, so we have 1, 2, 3 numbers here, 3 numbers and 3 numbers, and then we are going to replace the 3 numbers with the octal, with the equivalent octal digit. So 010 is, what is 010 in how much? 5, is it? Okay, 5. 101.
2.
Are you sure 010 is 5?
2.
2, right? 101 is
5.
5. Huh? 101 is 5. Therefore, this number is equals to 552 base 8. Okay, so So when you want to change from binary to octal, this is shorthand. Shorthand conversions, okay? So if you want to change from binary to octal, all you have to do is starting from the least significant digit, you make groups of 3 and then you exchange the groups of 3 with the equivalent octal digit. Okay, okay, let's try one more. Okay, okay, how about this? Anybody can tell me the answer first? Yeah, anyone can. Okay, we start from the right. Yeah, let's do it together first. We start from the right. So 1, 2, 3, 3 digits, 3 digits. Here you only have 2. So what do? We add one more here. So it becomes, because it doesn't change the digit, okay? So what is 110?
6.
6.
Yeah. 010,
2.
2.
2, 011.
3.
3.
So this equals to 3 to 6 base 8. Okay. So that is how we change from binary to octal very quickly. Okay. As long as you know digits 0 to 7, you know what they are in binary, you can do this very fast. Okay. Okay. Similarly, we can change from binary to hexadecimal. For example, you have this number, okay? 110, 101. Okay, I want to change this to hexadecimal. So just now we saw that hexadecimal digits can be replaced by a 4-digit binary number. Therefore, from your right-hand side, you group them in 4s. Okay, this is 1 digit, this is 2 digit. So what is 0110 or 110 in base 16?
6.
6, you sure? Okay, 1101?
13.
13, okay? But we can't write here 13. So what is the alphabet that we should write?
D.
D.
D. Yes. So this is equals to D6 base 16. Okay, can understand? Okay, let's try one more. Okay. Okay, tell me very fast. What is this in base 16? Anyone?
CE.
Okay, let's try. Yeah. From the right hand side, 1, 2, 3, 4. Okay, so we have one group here, then we have another group here. So what do we do with this number? So normally we add the zeros in front. Okay, 0, 0, 0, 1. Okay, so this first number, this last number here, 1110 is
E.
E, correct? 1001,
9.
9.
9, and this one here is 1. Okay, so our number is 19E base 16. Okay, so this is how we change from binary to octal or hexadecimal quickly. Okay, for octal we group in 3s, for hexadecimal we group in 4s. Okay, so if you can change from binary to octal and hexadecimal, you also can change from the other way around, correct?
Yes.
Okay, let's do this example. 2, 4, 7, 8. Change this to binary number. So what do we do? Let's just separate it out first. 2, 4, 8. Now each digit replaced by the equivalent binary number. 7 is equals to
111.
111. 4 is
100.
2.
00.
Is that correct?
010. 2.
What is 2?
0, 1, 0.
1, 1, 0.
1, 0.
0, 1, 0. Okay. Okay, correct this number. So therefore, this is equivalent to 0, 1, 0, 1, 0, 0, 1, 1, 1, 2. Or we can eliminate the 0 in the front. Okay. 2 is also the same. Okay. So from octal, we can change it to binary. Okay. So if we want to change from another example, from hexadecimal to binary. So let's separate the numbers out. Okay. So let's, E is, you know that E is
1, 1, 1, 0.
is how much? 14, right?
14.
14 is equivalent to 1110, correct?
Yes.
Okay, 2,
0, 0, 1, 0.
7,
0, 1,
0, 1, 1, 1.
correct? A is 10. 10 is,
1, 0, 1, 0.
okay, now we just put this number together. 1, 0, 1, 0, 0, 1, 1, 1. Okay, so that's why it's important to write in 4 digits. Okay, you cannot write 7 as 1, 1, 1. Okay, then it will go wrong here. Okay, so 0, 0, 1, 0, 1, 1, 1, 0, base 16. Sorry, base 2. Base 2. Okay, so we have changed from base 16 to base 2 using shorthand method. Okay, so we know how to change from octal to binary and from hexadecimal to binary. Okay, and we also know how to change from binary to octal and binary to hexadecimal. Okay, okay, what if we had the same number? Okay, the same number A72E, we want to change this to octal. We want to change this to octal number. How do we do that? Using shorthand. So there's 2 steps, isn't it? From binary, from a hexadecimal, we have to change to hex number, we have to change to binary, and from binary, we change to octal. We can use all shorthand, okay? So we have already changed A72E base 16. We have already changed this to a binary number, okay? So A72E base 16 is equivalent to 1010010110101102. Now this number, we need to change it to octal. That means we have to start grouping this number from the right into threes. Okay, so 1, 2, 3 here, 1, 2, 3 here, 1, 2, 3. Okay, then we have 1, 2, 3, 1, 2, 3. Okay, so this number, just add 2 zeros here. Okay, so what is 110 in octal?
6.
6, 101,
5,
100,
4,
011,
3.
3.
2, 1. Correct?
Yes.
So this is 1, 2, 3, 4, 5, 6, base 8. Just check that all the digits, if it's base 8, you cannot have an 8 or above 8 number in your answer. That's all. Okay. So to use shorthand method, if you want to change from hex to octal, you have to change it to binary, regroup in 3, and you have your octal number. If it's the other way around, if you want to change from octal to hex, from octal change to binary, that means you group in 3s, change to binary. From binary, you have to group in 4s to change into hex numbers, hexadecimal numbers. Okay, can I understand this?
Yes, madam.
Madam,
Yes.
can I ask you something?
Yeah.
Why did when I use calculator, when I type too long, the answer is math error?
It's
For
too long.
binary.
Depends on the number of digits that your calculator allows. Are you typing in which number, which base?
Binary. I try to
Binary.
convert the A what tadi A something
Uh-huh.
to the binary, and I got the math error.
Okay, I'm not very sure why that happened, but the other than the calculator, you can use a converter like this, online converter. This is much easier. Okay, so if you want to, there's so many converters online. This is one. This one is for hex, decimal, octal, and binary. For shorthand, this is a very good one. Straight away you can use. So the calculator part, I'm not very sure whether it's to do with the number of digits or what. Okay, so maybe you can ask one of your friends later. Okay, I just want to ask one more question. Supposing you had this number 10110111, okay, and base 2, and you wanted to change this to base 4. Can you do this using the shorthand method?
Can.
Can? So how do you do it? Tell me why you can do it first.
Because they are base 2. Base
Yeah,
4.
because 4 is equals to the power 2, okay? So how do you do it? What is your first step?
Grouping into
Grouping in how many?
2.
Twos, very good. So you're going to group this in twos, okay? Okay, so what is 1, 1?
3.
3,
3, yeah? 1, 0 is
2,
2.
2, 0, 1 is 1,
1,
1.
1.
So this is 1, 1, 2, 3, base 4, okay? So this shorthand is only applicable for base 4, 2, 4, 8, 16, okay?